Knowing the aufbau order for the periodic table is a handy thing. It shows you where the electrons are as they go from low energy to high energy around an atom. And it gets so repetitive that eventually people develop a shorthand notation to describe it. Let's first take a look at the energies of atomic orbitals as they increase. And they're increasing as we go up this y-axis here. Each one of these little blocks would be analogous to the orbital notation, right? It would be a pair of electrons. And you might see an interesting thing happen. We go from the first shell to the second shell, to the more in the second shell, to the third shell, to more in the third shell, to the fourth shell, and then what? The third shell then becomes a little bit lower energy for the D block, and so they start to fill up an inner shell. So it goes 1, 2, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5, 6. So they start to fill up out of order, and in fact they start to drop as many as 2 shells as you go on. So probably the most interesting outcome of this is that although the successive shells can hold up to 32, even 50 electrons, the outer shell will never have more than 8 because inner shells will always subsequently fill up. That's the idea behind the octet rule, which of course has helium as an exception. The first shell only has 2, but this idea of 8 electrons in the outer shell is full is true infinitely. No matter how large the atom is, whether it's discovered or not even yet discovered, there'll never be more than 8 outer shell electrons. And here we look at the periodic table overall, and if you read this like a book, you should be able to follow the aufbau order. This is the S block, the D block, the P block, and the F block. So let's go ahead and try to read this like a book. That means we'll go across and then to the next row. Each row represents a shell. Each block represents a subshell. So give it a try. Note that when we get to here, 6s2, that's where the F block kicks in. So make a mental note of there and also there. If you see any periodic table, you'll see that there's really a missing section right there. Annoyingly, it's normally shifted over to account for an aufbau exception that drives students nuts. I prefer it when they just show the theoretical value here. Okay, regardless, let's read this baby. 1s2, 2s2, that's there. 2p6, out to neon. 3s2, 3p6, 4s2. Now you have to remember to drop a number here. That's where we're getting this discrepancy right there. 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then back up to the fourth shell, 4p6. 5s2, what comes next? 4d10, 5p6. 6s2, watch out for the weird part of the periodic table here. Sometimes they use little stars here to remind you to go down there. So we drop 2 shells now. 4f14. And then when you get to this one, just look for the next one. It should be right around there, except for those that shift due to the exception, which I don't want to talk about. And we're now back to 5D, 10, 6P6, 7S2, 5F14, 6D up to 10, and 7P up to 6. I believe that's known as oganesson, and that would complete our known universe, all the discovered elements so far, many of which, anything above 92, is artificial in nature. Let's just do this for magnesium. It would be 1s, we'll stop at 12. 1s2, 2s2, 2p6, 3s2. That's the electron configuration for magnesium. To make it a little easier, we're going to just go to the nearest noble gas and pick up from there. This is an allowed shortcut known as shorthand notation. Nearest noble gas is neon, which has all that stuff within it. It ends with 2p6. That's right there. So we'll just call that neon 3s2. Note the square brackets. For fluorine, we could do the same thing. However, it's an unfortunate choice because the nearest noble gas is 1s2. So you could just say helium, 2s2, 2p5. Are you starting to see the pattern? Try it for scandium, and we can go all the way out to 18, which is argon. So we then pick up from argon, which went all the way to 3p6, and we just would have to say argon 4s2 3d1. Now you're saving some real time, and for the bigger ones you save even more. So that is the aufbau order with shorthand notation.